Problem number 19. Find the interval of convergence of this power series, the sum of n from 2 to infinity, 4 to the n times x to the n, divided by natural log of n to the n. Now, usually when we think about intervals of convergence of power series, we almost always use the ratio test. However, I note here that every part here, 4 to the n, x to the n, natural log of n to the n, we could rewrite this as the sum of n is equal to 2 to infinity of 4x over natural log of n to the nth power. So this is actually suggestive that we should think about trying to use the root test here. That let's take the nth root of the absolute value of the individual terms here and see what happens. Okay, so we want to, and then take the limit of that. So we're thinking about the absolute value of a sub n to the 1 over n power. Absolute value a sub n, so that would be 4x over natural log n. All of that to the nth power, to the 1 over n power. Rearranging this, we're going to make it look more like this. The 4 in the natural log, those aren't going to be negative. 4 is never going to be negative, and natural log of n, if n is at least 2, that's always going to be positive. So we can rewrite this, and things cancel, as 4 to the n, 1 over n, natural log of n to the 1 over n, an absolute value of x raised to the n to the 1 over n. So when all of those n times 1 over n's cancel, we're just left with 4 over natural log n, an absolute value of x upstairs. Okay, so let's take the limit as n goes to infinity of this. And so we would end up with the limit of 4 times absolute value x divided by natural log of n. That 4 and absolute value x, they don't have anything to do with n, so we can move them outside the limit. And when we do that, oops, I need to move them outside. 4 absolute value x times the limit as n goes to infinity of 1 over natural log of n. Now what happens as n goes to infinity, natural log of n goes to infinity, so this whole thing goes to 0. And so that answer there is 0. And so what do we conclude here? So this is rho. We know that if rho is less than 1, the series absolutely converges. And so the punchline here is rho is always less than 1. Rho is 0. Rho is always less than 1, no matter what x is. So what is the interval of convergence? IOC down here. The radius of convergence is infinity. And the interval of convergence is from minus infinity to plus infinity. So, moral of the story, watch out for these kind of cases. This can happen as well. And also, every so often, we use the root test to determine convergence of a power series instead of the ratio test.